Number 29. Consider a quadrilateral with vertices A, -6, 4, B, 0, -8, C, 6, 4, and D, 0, 12. This quadrilateral can be classified as a what? Okay, so the first thing I'm going to do is just take these points and graph them on a coordinate plane. Now, on a real math test, you would have to draw this for yourself and you'll be a little bit more approximate, but for the sake of the video and for the sake of simplicity, I'm just going to use this that I got off the internet. All right, so A is -6, 4, so that'll be 1, 2, 3, 4, 5, 6. All right, so this right here is A. B is at 0, -8, so 1, 2, 3, 4, 5, 6, 7, 8. C is at 6, 4. That's right there. And then D is at 0, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's all the way at the top. So that's D. Okay, so if we just look at our answer choices, first of all, it looks like, well, it's pretty clear that this isn't going to be a couple of things. So it's pretty clear that this isn't going to be a trapezoid. And it's pretty clear that this isn't going to be a square, because it appears that C and D are a lot closer to each other than C and B, for example. And if you have a square, then all the sides have to be the same. It could be a rectangle, it could be a rhombus, and it could be a kite. So let's think about some of these requirements. So to be a rectangle, these would have to be at right angles. So let's think about this. If they're at right angles, then we also know that they would have perpendicular slopes. So let's check and see if these have right angles. So for BC, the slope of BC, we would just do change in y divided by change in x. So to go from -8 to 4, that's an increase of 12. To go from 0 to 6, it's an increase in 6. So the slope of BC is 2. And then for CD, to go from 4 to 12, that's increasing by 8. To go from 6 to 0, that's -6. So there's -4/3. So those are not perpendicular slopes because they're not opposite reciprocals of each other. And so we know it can't be a rectangle. It can't be a rectangle because DC and CB don't form a right angle. So let's look at our other options. So if it's a rhombus, then we know that all of them have to be equal lengths. Also, they're just at slight angles, which is still fine. All we proved is that they're not perpendicular. So if we take two of these segments, we'll just use CD and BC again. We could show if they are equal lengths. Just by looking at this, it does not appear that they are. But again, on your math test, you wouldn't have as precise of a coordinate plane as I have, and so you still want to check. So CD, just do some distance formula. So distance between the x's is 6, so 6 squared. Distance between your y's is 8, 4 to 12, so 8 squared. So that will be a distance of square root of 36 plus 64. So that's square root of 100, which is just 10. And then for BC, from 0 to 6, that is also 6 squared. From -8 to 4, that's 12. That's 12, so 12 squared. And then, so we have 6 squared plus 12 squared, which is 180, which is definitely more than the square root of 100, or at least it's different. So we know that these side lengths aren't the same, so we can eliminate rhombus. So the only option left is kite. Okay, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.